Good morning to one and all present over here. This is Dr. Ilango M.K., Professor, Department of Electrical and Electronics Engineering, K.S. Rangasamy College of Technology. Today I will explain to you that pressure measurement. See, we all know that we studied what is pressure. Pressure is the force per unit area exerted by a fluid on the surface of the container. In order to understand the pressure, we should know what is atmospheric pressure, absolute pressure, gauge pressure and vacuum pressure. Just I will recollect what are those things. See, atmospheric pressure, the pressure due to an air surrounding the Earth's surface is called as atmospheric pressure, and we have to look at the absolute pressure. Absolute pressure, it is known that pressure is a force per unit area when the interaction of fluid particles among themselves is zero. The zero pressure intensity will occur. This is possible only when the population of molecules is negligibly small, which means perfect vacuum. Hence, the pressure intensity measured from a state of perfect vacuum is called as absolute pressure. And when we look at the gauge pressure, the pressure measuring instrument generally measures the difference in between the unknown pressure and the atmospheric pressure. When the unknown pressure P is greater than the atmospheric pressure, that is shown in this figure. Atmospheric unknown pressure P is greater than the atmospheric pressure. The pressure measured by the measurement is called as gauge pressure, and the measurement process is called as gauge measurement process. In gauge pressure is zero referred against the ambient air pressure, so it is equal to absolute pressure minus atmospheric pressure. Negative signs generally we are going to omit it. And for vacuum pressure, pressure measuring instruments generally measures the difference in between the unknown pressure and the atmospheric pressure. Everyone we know that when the atmospheric pressure P at ATM is greater than the unknown pressure, the pressure measurement by the instrument is called as vacuum pressure. See, from that graphical representation, easily we can understand that is gauge pressure means that absolute pressure plus atmospheric pressure, and for absolute pressures, and for vacuum, what is this automatically? That absolute pressure is lesser than the atmospheric pressure. So here we can easily understand which type of measurement systems we are going to use it for the cases. And when we look at the types of measurement, see, there are two types of pressure measurements. One is low pressure measurements and another one is high and medium pressure measurements. Normally for low pressure measurements, manometer is going to use it, and high and medium pressure, Bourdon tube, pressure gauge, diaphragm, bellows gauge are going to be used it for the cases, and low vacuum and ultra high vacuum and very high pressures are going to be used it with the help of those mentioned methods. And when we look at the pressure measurement types, there are two types: mechanical pressure measurement and electrical pressure measurements. Under mechanical pressure measurements, U-tube, manometer, Bourdon tube, bellows, diaphragm are the types of mechanical pressure measurement. And in electrical side, strain gauge, capacitive sensor, potentiometric, resonant wire, piezoelectric, magnetic and optical are the types of electrical pressure measurement. When we comparing with that of electrical, that mechanical pressure measurements devices are large and it is slow. Like normally the responses by the mechanical method, mechanical pressure measurement is slow, so it is not suited for automated control loops typically in industry. See, we all know that why do we go for pressure measurement by means of control only we are going to do it everything, but with the help of mechanical pressure measurement it is not suitable for the cases because of slow operations. Anyhow, I will explain one by one. The first one, types of pressure measurement under mechanical category. U-tube manometer. Actually in U-tube manometer, it measures the difference in between pressure between 2 points in a pipe. See, it is a U-shaped pipe shown in this slide. Depends on the pressure which is applied over that. what is this difference we are going to measure with the help of this arrangement. This is U-tube manometer. Typically we are using in these laboratory cases. And for the second case of mechanical pressure measurement, Bourdon tube, here the flexible element used as the sensor. Flexible element used as the sensor. Pressure changes cause change in the element position. See from this slide, you know that the second diagram, if pressure is applied over this point, what is this? Automatically it will changes the element position. It will changes the element position. This arrangement is called as Bourdon tube. Through this Bourdon tube we are applying the pressure. So due to the pressure, the Bourdon tube is going to be changes the position. So by the link and sector, the pointer is going to be deflected over that. The deflection point, the deflection produced by this Bourdon tube is directly proportional to how much amount of pressure we are applying over there. Here the element connected to point or reference pressure, easily we are going to measure. And the second one, bellows and diaphragm. The left hand side animation picture shows the bellows arrangement, and right hand side animation picture shows that diaphragm, how we are going to measure the pressure, right? Just similar to that of Bourdon tube pressure measurement, bellows and diaphragm is also going to be used. It is widely used because they require less space and can be made from material that resists corrosion. Actually, corrosion is one of the main problem under the maintenance category. So it is resist for corrosion. So easily they are going to use it for the cases, right? See here, if pressure is applied in that bellows, automatically the spring resistances is going to be elaborated. By this arrangement, what is this? Deflection is going to be made over that. This is for bellows pressure measurement. And for diaphragm, what is this? If pressure applied over that, depends on the pressure, what is this? It will make a move. It will make a move. So the diaphragm is going to changes over that. By means of the changes, pressure is going to be measured. And the next one, strain gauge. That is under the electrical pressure measurement. Here the strain based on the pressure applied, what is this? Strain gauge is going to be changes the resistances values, right? See, in previous classes I explained to you that the basic principle of strain gauge. What is this? Here just we are applying the pressure, so that means strain is going to be applied over that. So by means of the strain, what happened? The resistances are going to be connected with the circuit is going to changes, and with the help of Wheatstone bridge, easily we can measure how much amount of the value of resistances, right? See, the changes of resistances is directly proportional to how much amount of pressure we applied over that, right? See, this is the basic principle of strain gauge, which is used to measure the pressure. And the next one, capacitive sensor. It is also going to be used for the pressure measurement. We know the basic formula for capacitance. C is equal to epsilon area by D, where D is the distances and area is the area in between two dielectric medium of capacitance. And here, if you have to apply the pressure, what is this? Automatically the distance in between the two plates of the capacitor is going to be changes over that. So automatically the capacitance effect is going to be changes, and with the help of bridge arrangement, it may be a Desartes bridge or sharing bridge arrangement, easily we can measure how much amount of how much value of capacitance changes. Here the capacitance changes is directly proportional to what? How much amount of pressure we are applying. That is nothing but the pressure, the quantity to be measured, right? So with the help of capacitive sensor, easily we can measure the pressure. And the next one, piezoelectric transducer. We are also going to say the transducer, and with the help of piezoelectric principle, pressure is also going to be measured. And in previous classes I explained that piezoelectric transducer. Here the difference in between piezoelectric and strain gauge principle is what? Here if you have to apply the pressure, what is this? The resistances is going to changes over that. This is called strain gauge principle, and by applying the pressure, shape of the element, shape of the material is going to changes over that. That is called as a piezoelectric effect, and by changes the shape of the element, voltage is going to be developed with the help of voltmeter. We can easily measure. So how much amount of voltage is generated? It is directly proportional to how much amount of pressure we are applying over that, right? See, this is the operating principle of a piezoelectric transducer or piezoelectric pressure measurement, and it is the difference in between piezoelectric pressure measurement and the strain gauge pressure measurement. And potentiometer, we all know that by changing the resistances values, we are going to measure it, right? See, depends on the pressure we are applying over that. Automatically the connecting lead, which is going to be connected with the resistance path, is going to changes over that. So with the help of again some ohm meter, we are or any voltmeter, we are easily measures the values of a voltage. Here the voltage developed is directly proportional to resistance connected with the circuit, and the resistance connected with the circuit is directly proportional to how much amount of pressure we are applying, right? So depends on the pressure versus the movement element is going to varied over that. So with the help of them, we can easily measure the pressure. Thank you.